Hello everyone, my name is Victor. I'm from Norway. I currently work as a consultant at Soprasteria as a data engineer. For the past few years, I've been working with Databricks on Azure and AWS within the sectors of transport, telecom, and Horeca. So in this session, I'm going to speak about a fictional company, but with real world problems, to illustrate how Databricks can be a solution and to show Databricks capabilities from a point of view of a fictional company. This fictional company is named Contoso. It's a mid-sized manufacturing company, producing products for both consumers and business. Contoso have multiple departments, which all uses data, such as production planners, sourcing, customer care, web shops, and so on. All of these systems produce data, but also consumes it. With reports for day-to-day activities, enable to help them with day-to-day activities. So Contoso have a data warehouse where all these systems currently write their data to. And this data warehouse stores all the data, but it also contains a lot of business logics with jobs and procedures, creating data products for both Power BI reports, cubes, and more. However, it was set up a few years back, and times have changed. The current data warehouse is outdated. Contoso have experienced high growth for the past few years, and they feel like they reached the ceiling, and that it's not really the right platform for them going into the future. They feel like they've been locked in to the solution they already have today, because they have limited technological options. For example, they recently bought a new production line, which provides sensor data, which they can use. However, the data warehouse lacks the capabilities to use this sensor data, and it's old and therefore difficult to hire for, with poorly motivated employees. These employees want to work with new technology. Hence, the development is slow, and pipelines have not been maintained properly. There's a lot of complexity with little transparency, and the pipelines are slow. The on-prem data warehouse needs to be upgraded with hardware. So they have the data, but not the tools, and people are quitting. Now they are seeking a solution that solves today and tomorrow's problems, because they want to migrate to more modern data platform. They want to move to cloud, more tools, and to be able to extract more insight from their data, and perhaps also effectivize some manual processes along the way. Senior management, they want to reduce the cost for on-prem. There's a lot of maintenance going on, and new equipment needs to be bought all the time. And at the same time, they want better scalability, because they want to extract more from their data. And they know it's possible to use the data they have better. And perhaps they also want to include some machine learning models, but they for sure want to utilize the streaming data they have. So the senior management wants to know more about Databricks. They heard it's a popular cloud platform, which introduces concepts such as data lake and notebooks. Since it's in the cloud, they heard it's scalable, and it's possibly the platform they want to use, enable to grow and evolve further on. And besides, because it's popular, they think it could be also easier to hire for. Databricks also runs on Azure, which they have heard. That fits Contoso well, since they're already using Azure services, such as AD for identity and access management, but also Power BI for reports and insights. However, they want to prevent lock-in. And they heard that Databricks can run on multiple clouds, such as GCP and AWS. And they think that it would be easier for them to lift and shift if they want to move from Azure down the road. And they want to know more about the capabilities and how that might fit them. So let's take a step back and look at the current landscape. So they have a data warehouse with data from various systems and departments. This data is transformed and applied business logic to, with pipelines and stored procedures, creating enriched and curated data tables and data products, which is used by the whole organization. Yes, and they also bought this new production line, introducing sensory data, which is now currently being written to a Kafka topic, but it's not currently in use. But they want to use it to create value. And this is the latest and greatest in Contoso, because Contoso is an old organization with a lot of manual processes, and management have been told that some of the departments could be effectivized. For example, some tasks involve exporting data to Excel and combine, join, and transform them. We'll get back to this later on. So, today, systems write data to the data warehouse, but it takes time to switch and move to a new platform. It's a step-by-step in a transition period. So, they've been advised to copy the data, copy the raw data onto the cloud to replicate the business logic, and then later on configure the system to both read and write from the cloud. So, let's boil it down a bit. So, they need to extract data from the current data warehouse to the cloud to facilitate the transition. They also need to apply business logic and replicate the data products in the cloud. And they would need to do API calls to enrich the raw data and to automate manual tasks, which are today done in Excel. In addition, they want to stream the data from the production line and perhaps also do operations and actions in real time. And they need to store it in a way so that other systems can use it. And everything needs to be orchestrated, making the pipelines less complex and convoluted, bringing more transparency, making it easier for data engineers to use and maintain. So these pain points can be organized. Data extraction and transformation could be solved with notebooks, and orchestrations could be solved with workflows, streaming with data live tables, storage with Unity Catalog. But what are notebooks, workflows, data live tables, and Unity Catalog? And how can those components help Contoso? Let's start with notebooks and with Spark. So what is Spark? Spark is a distributed computing framework. It's the engine of the notebooks in Databricks. You run the code, and Spark takes the workload and spreads it efficiently over the available computer resources. And since you are in the cloud, it can easily be scaled up, making it efficient on larger workloads. And Spark is the engine of notebooks. But what are notebooks? Notebooks is Databricks' offering for replicating Contoso's business logic. It provides an interactive environment where developers can write, execute, collaborate on development and deployment. It supports R, SQL, Python, and Scala. It's quite similar to Jupyter Notebooks, with cells being either in Markdown or in code. So, when Contoso has created the code in notebooks with workloads using Spark, this is of no use if it's run manually. They need to create pipelines for the business logic in a way that prevents too much complexity. This brings us to workflows. Workflows gives Contoso the possibility to orchestrate pipelines with business logic and dependencies on whether a table has been created or not, and to things to be run in parallel or even in sequence before proceeding to the next task. And this is, of course, orchestrated as Contoso wants it to run. So, by running notebooks in workflows, it gives Contoso a lot of possibilities, like dbutils, for example. dbutils brings a lot of functionalities. One of them being able provides the Contoso the possibility to pass values from one notebook to the other. Here in this picture is passing pass on test file name from task 1 to task 2, and then in task 2 it's printed. This is just an example which can be further developed in more advanced pipelines. And as you can see, it can also be used to have logical flows within the data pipeline. Like, for example, here. You can build upon DB-utils and create pipelines with logical routing. For example, in this case, if the score is less than 0.9, it would trigger it could trigger a retraining if the criteria is not met, and if the model is good enough, it will be used to predict. This is perfect for creating the flow in Contoso's machine learning model. The Contoso's pipelines are going to run often, and the machine learning model possibly multiple times per day, with lots of different runs to keep track of. Thankfully, Databricks provides the possibility to have an overview and to manage this. For each time a pipeline is run, the instance is saved, and it stores detailed information about the job run, such as start time, end time, duration, and exit codes. The developers in Contoso can easily open each of these workflows to see what went wrong, fix it, and to get a clear view over how long different tasks took, and so on. This reduces complexity. And as you can see on the top, you have a type of errors doing on the job level as well. So, with logic in notebooks and pipelines in workflows, what about data quality? This brings us over to data lib tables, which supplements workflows by adding more functionalities, which are particularly relevant for the streaming use case. So, data lib tables is a framework for building data pipelines and to manage data flow between delta tables. It simplifies the work for data engineers doing development and management. And it complements workflows by providing more functionality, such as data quality, automatic recovery if something happens, and backfilling if a pipeline crashes. Data lib tables knows what has been ingested, and if something happens and crashes, and there's still more data available that is not being loaded, data lib tables can easily fill in what's missing. And in addition, it provides data quality constraints, which can be used when for the streaming use case of Contoso because of faulty sensors. And data lib tables supports both batch and streaming. This is the tool Contoso should use for streaming the sensor data. So, with logic written in notebooks, orchestrated in workflows, or perhaps in streaming live tables. However, Contoso will need to store the data somewhere. This brings us to Unity Catalog. Unity Catalog unifies security, governance, and cataloging. So, what is Unity Catalog? Unity Catalog is a metastore component of Databricks. It does not directly store data, but it builds on top of the Delta Lake, such as in GCP, Azure, or AWS. Delta tables are stored in storage account and containers, and Unity Catalog acts as a layer, interaction layer between the end users and the data. And users read and write tables through Unity Catalog, and Unity Catalog keeps all the metadata. So let's further elaborate on Unity Catalog. Unity Catalog got a lot to offer, such as Metastore, which provides data about data, such as permissions given, actions taken on the data, data types, last refresh, and versions. So if you experience that the table, there's something wrong with the table, you can easily, with Metastore, roll back to a previous version of the table. And Lineage Explorer. This allows end users to see the lineage of tables, notebooks, and columns. It makes it easier for the developers of Contoso to maintain and get a better understanding of the data flow. In addition, you have access control, which can be integrated with AD and user management as well, to control access to the Delta tables and to manage the access. For example, you can create groups in Azure AD, and you can provide these people in the groups access to various data products within Unity Catalog. And most importantly, you have audit logs, which logs the actions performed on the underlying data, who accessed and queried what and when. This gives fine-grained details for admins in Contoso to govern over the data products. So, can Databricks facilitate the Contoso's need for a new landscape? I would say yes. Data from various sources can be orchestrated and created logic with in both workflows and Delta Live tables. It can be refreshed with workflows, and the business logic can be written in notebooks or Delta Live tables. And Lineage and Data Explorer in Unity Catalog will help the data engineers get a better understanding of the data. Along with streaming of the sensor data, Databricks got streaming capabilities with built-in data quality assurances. And because it's so versatile, it can be used to effectivize manual tasks with business logic in notebooks and querying and so on. Here you can replicate and translate the manual tasks done in Excel to code. So, how does Databricks encompass Contoso's pain points? Let's dive deeper. So, let's get back to the pain points and start off with the first component I spoke about, notebooks. How can notebooks help with batch extraction, API calls, and transformation for Contoso? One of the needs of Contoso is able to extract data from the current data warehouse and ingest them into Unity Catalog. But how would they do that? Because Databricks brings so much flexibility, Contoso can set up JDBC or ODBC connections to the on-prem data warehouse. This allows for direct querying in Databricks and the possibility to save the table as Delta tables further on. And of course, Spark supports JDBC and ODBC, and it spreads the workload in an efficient way. This sounds good. However, it's not a recommended solution. It's a good solution and a feasible solution for ad hoc queries, but not for long-running queries. That's because if something happens which causes the cluster to lose connection to the on-prem server, or something else were to happen, the whole data transfer will need to start over again. This is because Databricks is not built to get data, only process it. Databricks is not good at connecting directly to sources. However, it's good at reading files in the cloud. So a more advisable solution would be to use integration tools such as Data Factory or SnapLogic. These can be set up to read data from the on-prem data warehouse and write the raw files to the cloud. And then Databricks can ingest these files into the raw layer and later transform them into enriched and curated tables. And to do this, Databricks advises to use Autoloader. Well, what is Autoloader? Autoloader is a strong alternative to long-running queries in ODBC and JDBC. It can be configured to continuously wait for new files and process them as they arrive, or it can be triggered when new files arrive, and keeps tracks of what has been ingested, both on the file level, but also on the content level. It does so by creating checkpoints and microbatches. And if something were to happen, it restarts from the last checkpoints. And because we're in the cloud, this can be scaled to ingest millions of files per hour. Using Autoloader would be best practice for Contoso. So, ingested data needs to be transformed before being put to use. And they need to use API calls to enrich data to reduce manual processes. So, let's go into an example of this manual process. It's with regards to cost allocation of Microsoft licenses. Today, this is done manually, combining consumption data from AD, license costs from the invoice, and cost locations from the HR data. All of this is combined in Excel with multiple files. And the employee needs to structure this data into a template so it can be uploaded into ERP. This is manual, frustrating, and prone to errors. So Contoso can automate such tasks with Databricks. Instead of downloading reports, Excel files, it can run an API call to Azure AD, or perhaps it's already stored in their data lake. And it can read invoices. Perhaps the invoice is in PDF, and logic in Python could be written in Databricks to extract what is needed from the invoice. Or perhaps it's already stored in a Delta Lake already. This, of course, needs to be combined with the cost locations of the employees having the licenses. Perhaps this data already exists as Delta in the Delta Lake. And because you can use this, you reduce also the need to manually download the file. And all of this can be programmatically joined together in Databricks, reducing human error and mistakes. And of course, when you do this in the cloud and with Databricks, you can visualize the consumption in a Power BI report. And because it's done programmatically, you reduce the human errors, which also makes it possible for you to implement checks and flags. Perhaps some users is set up with the wrong cost location, or perhaps they have too many licenses. This can be easily visualized in Power BI. And because you need to manually upload the file, which is what the person is doing already, Databricks can write the Excel file in the template needed to a SharePoint location, and then alert the users of when the file is ready. But this is also inefficient in a way, because you're relying on a person to upload the file. So perhaps Databricks can, so perhaps Contoso can use an API down the road instead of manually uploading it. So let's do a little summary. Databricks is a strong tool, but it's made for ingestion and processing and not for integration. And Contoso should use Autoloader and not rely on ODBC or JDBC, but instead use integration tools such as ADF. And it's flexible. It can run with multiple sources, and you can store both business logic in pipelines and effectivize manual tasks. So let's move on. It's worthless to have all of this if it's done, if you need to run it manually every single day. So Contoso should create pipelines in workflows and run notebooks inside of them. So to orchestrate this license report, they run a notebook with API calls to get the consumption, and then to get the invoice, and then to get the cost location of the employees. All of these are stored in individual raw tables when they are finished. And all of them need to be finished before it combines them and performs the logic and structures the data into the template needed. Then, when the logic is done and the data is saved, you can trigger a Power BI refresh of the data. And you can store the share to SharePoint and alert the user that now it's okay to upload the file. This can be done through both Slack, Teams, and email. But perhaps Contoso have multiple pipelines, both refreshing Power BI data, but also writing to SharePoint. What were to happen if a connection changes? Or Contoso would need to make other adjustments? Then they risk having to having to do maintenance on tens of notebooks. They should instead use one notebook for Power BI and SharePoint, and rather use DB utils with parameters and send values into the notebook, refreshing the Power BI report or storing it to SharePoint. Like for example here. And this can further be, it can also be added more parameters after the need. This increases the efficiency and prevents Contoso from having a mess of jobs all over the place due to poor maintenance. And for example here, another use case, where Contoso first starts with a bunch of bronze tables, which is then enriched and curated into silver and gold tables. Then it's combined into a larger table, which is then used in a Power BI report that is refreshed when the data is ready, but also used to create features for a machine learning model, which is retrained when the day is Sunday. But it is in use every single day. And Databricks should also alert the users when there's a surge in popularity. So let's sum up workflows a bit. You can use parameters in workflows and notebooks, which makes them more reusable and preventing unmanageable pipelines and workflows. The logical flow inside workflows, it gives you the flexibility to set up logic for what will happen next, based on what has been processed. And it also gives the possibility of alerting the users when a new file is ready to be uploaded to the ERP, or when a value goes over or under a threshold. So, Contoso can set up batch processing and a simple machine learning model. But how can Delta Live tables fit into their streaming use case? They currently have sensors writing to a Kafka topic, but they need to put to use. And as I mentioned, Delta Live tables would be a feasible solution for Contoso. As I previously mentioned, Autoloader could be used to ingest the data. And it can be run every night, or every hour, or as a new file arrives. It can be scaled to the frequency you want. That also means that Autoloader can be used to stream files as well, ingesting data as soon as it arrives. When working with streaming data, it's advised to use Delta Live tables. And for the Kafka data and the streaming use case, Contoso is advised to use Delta Live tables, because Delta Live tables complement workflows, as I mentioned, with data quality testing. And let's see why. So Delta Live tables should be used for the sensor data. Sensors have a tendency of producing bad data. Perhaps pressure in the tank shifts every second, or maybe a temperature sensor shows a temperature that is hotter than the surface of the sun, or something familiar. Perhaps there are missing values, faulty equipment. So, is the reason for this faulty equipment, or is it actually real? We need to set up data quality tests. And this is one of the functionalities that's supplemented with Delta Live tables. So for example, in this slide, data is streamed into a raw Delta table, transformed, and data quality is assessed. Does the temperature fall outside what could be addressed as normal? And if the data is bad, it can be stored separately. And users, data engineers can look into this data further on and see what went wrong. And also it can be visualized in Power BI. And perhaps you can make a data project here for where maintenance crew can be deployed to fix what might have gone wrong. But if the data is good, it can be stored as enriched data and perhaps also trigger an API call on the production line. And because sensor data can deliver data every second, that might not be relevant for them to report on. So perhaps to do some sort of aggregation to get data every 5 minutes or every 1 minute, which can be stored as a curated data and visualized in Power BI. So this little summary of streaming data. Autoloader supports both batch and streaming, and Delta Live tables should be used for the Kafka streaming use case, which includes data quality in the workflow, with logical flow based on data quality. Now, with data transformed and streamed, it should be stored somewhere and made available to the users. So let's go back a bit. Contoso is in a transition period, where raw data is made available in the cloud, so the engineers can recreate the business logic. And then later on, the on-prem can be phased out. And the transition period is over. system needs to be configured to read from cloud. With data being exported through ADF and ingested with autoloader. But perhaps some system might support writing delta tables. How would that work with Unity Catalog? So like I previously mentioned, Unity Catalog is a layer between the user and the delta lake tables stored in ADLS. If a system can write delta tables, it can be written to ADLS and then exposed to the users through Unity Catalog. And they Composer would then benefit from the auditing. This means that you'll be able to skip a step of ingesting the data with autoloader by writing the tables themselves. So in this picture, the production and sourcing system writes delta lake tables in their own storage accounts. And Unity Catalog makes the tables available to the users. However, it does not perform any altering on the tables, only reads and makes them available to the user. Notice the arrows. And these users consuming the data might create tables that they need to use in reports or some other things. And when writing it in Unity Catalog, it can be written to their own storage account. So it's all possible to separate. And by doing so, and by having systems write delta tables, we can drop using autoloader and skip this whole step, making our new architecture look like this. Data would be available as raw straight away. So we have now covered the system transition and how data will be stored and used in Unity Catalog. There is no value if it's not being used. Other systems in Contoso needs data, like for example Power BI, but also perhaps CRM, ERP, or other custom applications, which consumes this data enable to produce an output. And Contoso got two main pathways to connect to the data. One alternative is delta sharing, and the other one is by querying the data directly in ADLS. And because data is not stored in databases, but files in ADLS, it provides flexibility. However, when querying data directly from ADLS and not through delta sharing, it does not provide any auditing and logging capabilities, and governance would be more difficult to do. So therefore, delta sharing is advised to use, and that would give Contoso the possibility to govern the data better. And they should use delta sharing because it's designed to share data across organizational boundaries. It's an open standard, which is open source for secure data sharing. For example, Contoso might use an ad agency for their marketing. And this ad agency might need data from Contoso. And with delta sharing, you can share it directly into their own workspace in Unity Catalog or directly into another program. And of course, since you go through delta sharing, it gives Contoso the full governance and auditing logs that I previously mentioned, making it easy to track and audit if something happens. And of course, this can be queried using standard SQL or other compatible tools. And delta sharing is widely supported. So, Contoso system can write delta tables which can be exposed to Unity Catalog. This makes the data accessible in multiple ways, but it also prevents lock-in, making the data easily shareable across systems. So, Contoso and Databricks, is it a good fit? I have now talked about how Contoso can use Databricks and notebooks covering data transformation and data extraction, which can be parameterized to reduce maintenance. And Databricks brings workflows for orchestration and Delta Live tables for streaming and batch ingestion, along with data quality, and Unity Catalog for storage and governance, giving the administrators the possibility to govern their data. So all in all, I think Databricks will be a great fit for Contoso. It meets their requirements for data extraction and logic, and streaming of data as well, and to effectivize manual tasks. It's a great platform for Contoso's future. Thank you.